Hello everyone. Today, I'd like to talk about our paper accepted by the CVPR 2026. Our paper called D2Cache, second order third caching for higher video acceleration. And my name is Enhuai Liu, and I'm from the University of Sydney. Okay, and let's get started. At first, I like to talk about the background. Video diffusion models are popular now and they can generate high quality videos, but it is quite slow at the inference. A single video generation requires hundreds of noise steps, which takes several minutes even on a high-end CPU, which limits the deployment of the video diffusion, like some applications such as live editing and AR. And till now, there are three main acceleration approaches. The first direction is sampling reductions. It reduces the diffusion steps of video diffusion, and but it causes some artifacts. And the second direction is the knowledge distillation. It works well, but it requires retraining, which is quite expensive. And the third approach is the caching method. The caching method is training free, and our method focuses on this way. At first, I like to explain how the previous first order data caching works. Almost all the previous caching works is the first order data caching. And you can see here at first for the first order data caching, it divides all the diffusion steps to the compute steps and the caching steps. And at each compute steps, it calculates the first order data, uses the output of this step minus the input. It caches this first order data, and for all the following caching steps, it directly adds this data to the input and gets the output of this step. And after several caching steps, it recomputes the first order data and refresh the cache. And it do the same thing across all the time steps during the diffusion process. It works well, but the first order data at each caching step causes error accumulation. So to further dealing with this, we have some key observations. Other key observation is that we can use the second order data to refine the error in the first order data. And at the left part, you can see here across three different video diffusion models, this green line is the LR norm of the first order data, and the red line is the LR norm value of second order data. You can see here is that the LR norm data has a quite lower value and fluctuations than the first order data, which means it is more stable and it can be used to refine the first order caused by the first order data. And also, at the right part, you can see here there is a strong correlation with the second order data and time step embedding, which means we can use the time step embedding to estimate the magnitude of the second order data. So after we got these key observations, we designed the main pipeline of the D2Cache. You can see here, unlike the previous first order data caching at the bottom branch, we additionally add a top branch here. It's called second order data caching. For each caching step, we not only add the first order data here, but also we use second order data computed by two previous compute steps and add it and dynamic scale it by time span embedding. And we not only add the first order data, but also add the second order data, add the scaled second order data to get the final result of the caching steps and further reduce the error and get better results. And here is the experimental results. You can see here at the left part, the D2Cache performance is better than T-Cache, the first order data caching. They are all on the same caching strategy, but the performance consistently lies higher on than the T-Cache. It has a better performance at each speed-up ratio. And on the right part is the detailed results. And also we can see some visualizations. You can see here this video is generated by default T-Cache and D2Cache. They are under the same speed-up ratio, and here we state. You can see that the details by D-Cache is blurred, but the details of D2Cache is sharp and clear. You can see it here also. You can see for this man's hand and the robot, it have better details. Okay, that's all. Thank you for listening.